Hello everybody, today we will try to save this charger for lead acid batteries. This is pretty cheap, about $25, something like this, and obviously it's not working. The man who brought it to me said it's not supplying any current to the battery. Now it's turned on, and as you can see its output is 4.6 volts, which is kind of low. And here I have old lead battery that I took out of an old UPS. The battery is very bad, it has high internal resistance, but it would be enough for us to check the charger. As you can see, probably, I hope you can see, it shows that it's charging and it switched from 6 volts to 12 volts, but because the device has not any current meter, so we cannot make sure that it is supplying any current. That's why I take this analog ammeter with a shunt. I showed it to you in a previous video how I made it. Actually it is an electronic load, and I had laying around a shunt and 15 amps meter, and I just put it inside this housing. And sometimes I use it because my multimeter is capable of measuring 10 amps. I don't have current clamp meter, so 15 amps sometimes are needed, but here there is no consumption. As you can see, the needle is not moving, which says charger, we've got a problem. Let's try it one more time, and now it is showing an error. Error is blinking. Now it's not reacting to anything. So that's why I'm gonna open it, see inside. Maybe I will be able to fix it. That's the back side. It's automatic charger for all lead batteries 6 and 12 volts, the writing was saying. And it's pretty simple, as you can see. Switch mode, power supply, no high tech inside. Very simple, and that's why it is cheap. Let's remove the screws, get the PCB out, and actually I can already see the problem, at least one problem, which might be the only one. That is P-channel MOSFET, and as you can see it has a hole. You can see those tiny wires that were going from crystal. It's a basic P-channel MOSFET, 40 volts, 13 amps, nothing special. Now I'm gonna get a special purpose thermal pad. You can buy it in my link below. Very convenient, very heat resistant, much better than silicone, but it is conductive, so you have to be careful. Of course, I'm kidding. It's just a base of an old iron. Okay, I removed the bad guy, and where we can find a good guy, of course, if somebody knows repairs, somebody does repairs, that you should know that on some laptop motherboards there are P-channel MOSFETs at the input with the same values, plus and minus, about the same. So I took one, as you can see. There are two of them, I took one, and now I'm gonna put it in place. It is the same case, same legs. Push a little bit of flux with my finger, just like this, and put this guy in place. Also, I checked the gate of that transistor, and the gate was not shorted. I mean, the gate on the PCB. The contact pad of the gate compared to the ground, and it had a very high resistance, so we can say that whatever drives this gate is not shorted. So probably the only problem is the transistor itself. Now we can check whether it helped or not. Let's clean it a little bit with alcohol, for the sake of this video, of course. Put it back into the housing, just like it was before. We don't need that special purpose heat resistant thermal pad. And let's check. Are we lucky? Was it so easy? I hope it should be so easy, because for this price it shouldn't be difficult, because time is also precious. Our life is time, so we don't want to spend it for nothing. Okay, let's turn it on. Check the voltage, check the output voltage. As you remember, it was 4.6 volts before, and now it's 18 volts, which is much better. Let's take the same battery, connect it to the minus terminal, same emitter, plus here, minus with longer wire, and as you can see, the needle got up. It shows about 2 amps, actually even 2.5 amps. So it means that the battery is charging, it's taking current. As I said, the battery is old, but 14 volts as it's supposed to be. That's why we can consider this charger fixed. I think it's pretty easy job. If you have something like this and you have the tools, why not to bother yourself and fix this device? That's it for today. I hope you like it. I hope you find it useful. If you do, give it a thumb up. See you next time. Bye.